Hi, this is Travis, and today I want to talk to you about a statistical technique that you can use to understand the major problem areas that your users experience. We start with a list of 25 pain points, so a longer list, and then we look at how these pain points are related to one another and if they group together and form larger pain or problem areas. And this helps with defining your product and the major dimensions of your product. Once you know the main problem dimensions, then you can formulate your product dimensions to remedy each one, perhaps, or specific ones, depending on the market. We can also score each competitor on how they perform on these user problem areas, and this helps with product positioning to see if there are any unmet needs or gaps within the market so that we can position our product there. What we're doing is we're basing this all on customer survey data. And the idea is that we can take actual direct measurements with specific questions in a survey. We can ask customers how much they agree or disagree with statements, and these are direct measurements. And what factor analysis does, this is the statistical technique that we'll use, is something called Exploratory Factor Analysis, EFA. What it does is it looks at how these direct measurements interrelate with one another, how they're correlated with one another, and how those correlations can group together. And they define factors based on this. So these factors are like hidden variables that are causing the responses in our direct measurements or our the variables that we include in our survey. I think a really cool example of EFA is how the field of psychology derived the Big Five personality theory. The Big Five personality theory states that individuals range in personality across five main personality dimensions: neuroticism, extroversion, openness, agreeableness, and conscientiousness. But how did they create these dimensions? They applied factor analysis to an enormous data set, which I'll explain later on, and derive these personality dimensions this way. The resulting model gave them five factors. So this data set was, the psych researchers looked at all the different adjectives and descriptive statements that you can use to describe people. And so they had many different versions of the survey, and they showed many different people different versions of the survey and asked them to rate the relevance of each of these descriptive terms in describing themselves. So how much does this statement relate to you? How much does it describe your personality? And so here's an example of five statements right here. Talk a lot, find it easy to approach others, know how to captivate people, make friends easily, and the life of the party. So they had people rate these on how relevant they are to their personality on, let's say, a 1 to 6 agree, disagree scale. I think we can all agree that on these five statements, if you rate these as higher, that you agree more, that they're more relevant to you and your personality, that you're more extroverted, and that the lower the rating, the less extroverted you are and more introverted you are. So what we're saying essentially is that these statements cluster together, and that if you give one of these statements a high rating, you're likely to give the other four statements a high rating because they co-vary and they correlate with one another. Well, this is what the factor model did in this psychological experiment. It pulled out five factors like this based on all the different descriptive terms that you could use to describe people, not just social outgoingness that I'm showing right here. And that was one of them. So one of the factors showed that these five statements loaded highly on that factor. So the researchers came after the fact, looked at what was loading on the factor, and decided to call that factor extroversion. They did the same for the other four variables, and that is how the Big Five personality theory was derived. So pretty interesting. So how does this relate to product design? Well, let's say that this is a two-phase study. The first phase was qualitative one-on-one interviews where we were trying to uncover the user issues with centralized cryptocurrency exchanges. And if you're not familiar with that, that's fine. These are just web apps that you can buy cryptocurrencies through. So it's a software like any other, and of course there's going to be usability issues associated with it. And we were trying to understand these usability issues. That's what we had these interviews focused on. So in the end, from phase 1, we ended with a list of 25 specific pain points. And here's 5 down here, but I'll just read one. I worry about harmful government regulation that CCEs may be subject to in the future, right? It's a specific point. It's a specific pain point. And we want to know how these 25 pain points interrelate with one another, and if they do. Because if somehow the pain points cluster together and are related to each other in these smaller groups, then I would say that those are major user problem areas. And so that's what we're going to do. In phase 2, we're going to try to discover these major user problem areas by applying EFA to a data set. We're going to have users on a scale from 1 to 6 rate each of the 25 pain point statements, telling us how relevant it is to their usage of CCEs, or cryptocurrency exchanges. So here's an example of what we do. How accurate or inaccurate are the following pain points related to your usage of centralized cryptocurrency exchanges? So we give them a 1 to 6 scale. They have to say whether it's accurate or inaccurate and to what degree. And then we have 5 statements here, but we're going to show them 5 of these question chunks, kind of like a block in Qualtrics. And so that's a total of 25 pain points. So similar to the psychology statements above, the pain points that relate to one another and that are correlated with one another may indicate a larger, more high-level user problem area. And we can use this to plan our product and to better understand the direction our product should take. So here's an example of the data that we get out here. We have 25 variables ranging from 1 to 6. These were all Likert scale questions, relevant or inaccurate to accurate. And then we have the platform that they're using. These are some of the current CCE platforms. We had respondents who use Coinbase, Binance, Kraken, just 3. And we stratified our sample across those so we could get more of a representative look at the current CCE landscape. One good thing to do when you have Likert scale data like this is to do something called standardize it or normalize it. What this is essentially is it's a data operation that it allows us to better compare Likert scale ratings between each respondent. Because with Likert scales, it's a well-known fact that there are scale use biases with it. For example, different respondents will use different parts of the scale compared to others. Like a 6 for somebody might be different for somebody else. And culturally, people use Likert scales differently. So to eliminate that or to mitigate the negative effects of scale use bias, we do something called standardization. What you do is from each basically, we take the average of this vector and we subtract it from each response. That's called centering. And then we take the standard deviation of this vector and then divide it by each of those centered responses. So those two processes, back to step 1, step 2, is standardization. You can do that manually, but I just do it with a function called scale in R. And we're only applying that to the first 25 columns because those are numeric. It doesn't obviously make sense to do that with the categorical platform variable. Now, as I said, exploratory factor analysis is looking for patterns in the correlation between variables. So a good first step before you run an EFA is to look at the correlation between variables. And what better way to do this than a correlation plot? It plots a matrix with all the variables on the y-axis, and then all the same variables on the x-axis. So the diagonal has a 1-to-1 correlation because it's comparing the same variable, and then it shows the intercorrelations between all the other variables. And we are definitely seeing pockets of high correlation. Like, look at this. This is, if I had to guess, like it's this block of questions are positively correlated with each other by 0.4 or more, just based on the coloring of the circle and the size of it. Same here, even larger, like these are very highly correlated variables. And then also I see negative correlation, a significant negative correlation down here. So this is a good sign. We don't have to think too much about it or look more into it than necessary. There are more effective or efficient ways to do this. But right now it's a good sign that we're seeing high positive and negative correlation amongst our variables. Before you run a factor model, you have to decide how many factors you're going to include. And this can be hard before you look at the data, really know what it's saying, to guess how many factors are there. So like any other statistical modeling technique, it's going to be iterative, and so we can fit a model and then change the number of factors after the fact based on those results. But just as a first guess, you can use analytical methods that will recommend a factor that will give you a factor number recommendation based on something called scree tests. So this function right here outputs the recommended number of factors for 4 different scree tests, and 3 of the 4 are recommending 6-factor solutions. Also, in other texts, they recommend to withhold the number of all factors with an eigenvalue greater than 1 right here. So anything less than 1 we would discard, and we would stick with, in this case, 1, 2, 3, 4, 5, 6. 6 factors have eigenvalues greater than 1. So again, both of these methods are telling us to go with 6 factors. So this is where we'll start for our initial model fit. We can think of a factor analysis happening in 2 steps. The first step is that the model extracts the number of factors that we specified, which is 6. And then the model rotates the factors. And rotation is a complex subject, but what it is trying to do is to maximize the interpretability of the factors in terms of our original variable set. What this essentially means is it's trying to maximize the variable loadings on each factor for a small subset of variables. And so that we can then think about that factor in terms of the small subset of variables. This is how we're going to interpret it in the back end. And that's the main output from a factor analysis, are how each of the original variables load onto each of the factors, which I'll show you here in a second. But just know that it happens in 2 parts: extract factors and then rotate factors to maximize interpretability. And so let's not get too much into the rotation, but it's important to talk about here because the default rotation method is something called Varimax, which assumes that the 6 factors that we're creating are not correlated. It allows 0 correlation between these factors. There are other methods called oblique rotation, which does allow correlation between the factors. And this comes down to your subject matter expert as a researcher. You're trying to, do you think that your factors or that these major user problem areas could be correlated with one another? That will depend, or that will inform which rotation method you use. In this case, I do believe that the factors or the user problems could be correlated with one another. So I proceed with an oblique rotation by calling something called oblemin in the function below. So factanal is the function that we use to fit this factor analysis model. I specify 6 factors based on the scree tests and eigenvalue tests that we saw above, and then oblemin, because I'm assuming that our factors can be correlated with one another. And the output shows something called factor loadings. So for each factor, we see the loading of each of the original variables in our data set. So each of the pain points load onto these factors. And the magnitude matters. The greater the magnitude of factor loading, the more that this factor explains the variance or influences the variable in our data set. indicates a stronger relationship between the pain point and the user problem or factor. And negative sign has meaning too, which I'll explain down here below. But this printout is a little daunting to look at. There are many different values. And but the main thing that I notice in this printout is that factor 6 has relatively small loadings compared to the others. Like right here I see like 0.8, 0.8, 0.6, right here 0.57, 0.67, 0.54, 0.6. So I see larger loadings on the first 5 factors, and factor 6 doesn't have anything above 0.324. So what I'm going to do is I'm going to drop factor 6 from the model because nothing is heavily loading on it, and run a 5-factor solution. And at the same time, I'm going to not print out any factor loadings unless they're 0.5 or more. Okay, so we can only see the variables that have the highest loadings. And so here's this output here, 0.5 cutoff, 5 factors, still using Obelman. The factors can still be correlated with one another. And if you look here, this really cleans up our, here, let me zoom out a little bit. This really cleans up the output. Now we can see. So clearly, Q16 through 18 heavily load on factor 1. For factor 2, Q2, 3, and 5 heavily load on factor 2. Factor 3, Q6 through Q10 are highly important. Factor 4, Q11, 12, and 14. And then for 5, Q21, 23, and 25 heavily load on that. The factors are nameless. We don't know what they are yet. We just know that there are groups of pain points that are highly related to each one of these factors. In these factors, if you're tracking my explanation so far, these factors are major user problem areas, right? It's not an individual pain point, it's something higher level and behind the pain point, something causing the pain point. We can also visualize this EFA with something called a SEM path, and SEM stands for Structural Equation Modeling Path. Right, so we can just visualize it here, and these are these arrows coming out of the factors are just the factor loadings corresponding to that variable. And these SEM paths, they imply causation. Factor 5 causes response in these variables. We are sensing a relationship between them. Now we need to interpret what the factors actually mean for us as a product designer or product manager. We want to understand intuitively what these factors are. These are the user problem areas. So in order to do that, I look at the variables that group together based on our EFA above for each factor. So factor 1, my daily deposit limit is too small. My daily withdrawal limit is too small. I had trouble transferring funds into my CCE wallet. For me, this is about bank integration. They're having trouble depositing and withdrawing, and they're having trouble transferring their funds. So this is issues with bank integration with their CCE wallet. Factor 2, I worry about harmful government regulation. The ethics of CCEs concern me. Centralization concerns me from the perspective of infrastructure risk like network downtimes. To me, this is about distrust in centralization and centralized authority in general, right? They're worried about government regulation. They're concerned about the ethics of CCEs, who have been known to fake trading volume, have insider trading, and manipulate the price. And also that centralization brings infrastructure risk. If everything is running through a centralized terminal or network, you don't have a distributed network to where if one goes down, the system can remain up and running. So this is, in my opinion, a general centralization risk. Factor 3, it bothers me that I don't have full control of my assets. As a central repository of assets, CCEs are a prime target for thieves and hackers. Immediately after purchasing, I transfer my assets to cold storage anyways. I trust CCEs to properly custody my assets with high security and privacy procedures. I'm okay leaving my assets in the CCE hot wallets. Okay, let's break down these pain points here on factor 3. The first 3 are negatively phrased, and the last 2 are more positively phrased, right? So this is where the negative sign comes in on the factor loading. For factor 3, the last 2 loadings should be negative in order for this to still make intuitive sense for us. So let's go back up and look at the factor loadings on factor 3, and the last 2 are indeed negative. And we do this, we flip the kind of the polarity of the statement that we give respondents just as an attention check to the respondents. So if everything is phrased negatively, it's easy for the respondent to go through and give a high, this pain point is really related to me, give a high rating for each one of those. But when we flip the polarity, it kind of shifts, it makes the survey flow less predictable to the respondent. And hopefully it slows down their decision making, their response process, and improves our data quality. So this is why I flipped the polarity in statements, and this is why we get negative loadings on the factors, and this is making intuitive sense for me. Going back to our interpretation of factor 3, I would say this has to do with security concerns and custody of assets. Factor 4, I do not understand how transaction fees are calculated. I never run into issues with daily purchase limits. CCE fees are reasonable. I'm willing to pay for the convenience. This is about transaction fees, purchase limits, and fees again. So I'm going to say transaction fees and purchase limits for factor 4. Factor 5, I do not earn interest on my assets like I do in my traditional savings. It bothers me that I am unable to lend, borrow, or collateralize my assets from my CCE wallet. I don't need smart contract functionality with the assets in my CCE wallet. To me, this means that the CCEs are lacking in the money verbs that we're used to talking about in terms of traditional finance, where you can lend and borrow your money, earn interest, collateralize your assets in order to borrow. So this is kind of overall it's a lack of functionality, and there's also this lack of, like, it doesn't have smart contracts like DeFi and apps built on Ethereum, for instance. So it's lacking functionality, and it's not connected or integrated well enough with decentralized apps. Cool, so now we know the major problem areas associated with CCE usage. And if we were trying to enter this market and compete, then we know the major dimensions that we'll have to define our product and then marketing statements on. Last analysis here, I know above you saw that in our data frame we have the platform that each user uses. So we can actually calculate a factor score for each CCE platform. And what a factor score is, it's essentially how well these platforms perform on the major user problem areas that we just defined above. And I'll show a heat map below where we can then get we can look at the market as a whole and see how the competitors perform, and then if there are gaps in the market, so that our product, we can go and fill that gap perhaps and not compete head to head with these more established platforms. But in order to calculate a factor score for the brand, first what we do is we calculate a factor score for each individual respondent, and then we average the factor scores across the users of each brand, if that makes sense. So here are the averaged factor scores here, and then I rename the factors to instead of 5 factors, the 5 major problem areas that I interpreted above: issues with bank integration, distrust, centralization, security and custody, transaction fees, lacks functionality with DApps. So the greater the factor score, it means the worse that a CCE performs on that problem area, or the bigger of a problem it is for that CCE. Instead of looking at these raw numbers, we can just quickly throw this data into a heat map and where the darker the red, the more of a problem it is for each CCE provider here. So we can see that Binance does poorly with transaction fees and lacks functionality with dApps. Coinbase does slightly better than both Binance and Kraken on those two problem areas. However, Coinbase is hit the hardest here on bank integration, security and custody, and distrust of centralization. Kraken kind of does poorly across the board. It has a relatively high red hue all across the 5 problem areas. So in this way, we can look to find gaps in the market, maybe decide who our competitor, who we're going to try to compete against most. Coinbase has the greatest market share, so if we wanted to try to win some of that market share from them, we could look to improve the product on these 3 problem dimensions right here. Thank you.